Directed graphs. A directed graph is a graph where you can travel only one direction along an edge, like a one-way street. For each edge in a directed graph, the vertex that the edge comes out of is called the starting vertex, and the vertex that the edge goes into is called the end vertex. This difference between a directed and undirected graph leads to a slight difference in the way we code them. For example, in an adjacency matrix, we know that for each edge in an undirected graph, we have to mark a 1 in two different places in the graph. This leads to a matrix for an undirected graph always being symmetrical. For a directed graph, however, for each edge in the graph, we're only going to mark one spot in the matrix. For example, for the edge that connects A and B, since A is the starting vertex, we'll go to row A, and then since B is the end vertex, we'll go to column B to mark the 1. Then, for the edge connecting B and C, B is the starting vertex, so we'll go to row B, and then C, the end vertex. And then for the edge connecting A and C, A is the starting vertex, C is the end vertex. And that's the only place we mark a 1 in. So, for that reason, the matrix for a directed graph will only contain half the number of 1s as its undirected counterpart. A similar change applies to the adjacency list structure. With an adjacency list, we know that for each edge in an undirected graph, both vertices must store the opposing vertex in its linked list. However, with a directed graph, only the starting vertex will store the opposing vertex in its linked list. For example, A will store both B and C in its linked list because there are edges that begin in A and end in B and C. However, B and C will not store A in its linked list. B, however, will store C in its linked list because there is an edge that starts in B and ends in C. But C will not store B in its linked list. In fact, C won't store any vertices in its linked list because there is no edge that starts in C, only edges that end in C.